In this next video, I'm going to attempt to show you the sine, cosine, and tangent of a special type of angle, which are called quadrantal angles. The first thing I want to do is I want to define a quadrantal angle. Quadrantal angles are angles whose terminal side lies on the x or y axis. So it's an angle in standard position. It's got to start on the x-axis, and then you rotate it so it ends up on a quadrantal axis, which means we're going to look at angles that are 0 degrees. So the terminal side would start on the same, or finish on the same side as the start, or a 90-degree angle would rotate around 90 degrees and land on the y-axis. A 180-degree angle, which would rotate around to 180 degrees. And if the terminal side was on the negative y-axis, that is a 270-degree angle. Or if we could do a full rotation all the way around and come back to where we started, that would be a 360 degrees. So we're looking at 270 degrees, 180 degree, and 90 degree, and 0 degree. These are called quadrantal angles. If you think of them in terms of radians, you would have 0, pi halves, pi, 3 pi halves, 2 pi, and so on. So considering all the wraparound angles, those are the ones we're trying to attack in this video and this part of the lesson. How do we define sine, cosine, and tangent of these specific angles? The way that I'm going to do that is I'm going to show you on this unit circle that I have here. What I have is a circle of radius 1, so you can verify the radius is 1, the x value is being calculated, the y value is being calculated for the red and for the blue here. So we have those values that we can trace. But what we want to do is make some observations as these angles get closer and closer to the quadrantal axis, or the angles of 0, 90, 180, 270, and 360. So our angle right now is 48 degrees approximately, and if I make that angle smaller and smaller as I approach 0, as our angle gets closer and closer to 0, the red line, or the y value, the side opposite the angle, becomes shorter and shorter, and that is getting closer and closer to a length of 0. On the other hand, if you look at the blue line down here on the adjacent side, as the angle becomes smaller or closer and closer to 0, so it's kind of like a limit idea, as x approaches, or as the angle approaches 0, x approaches the same length as the radius, and eventually when the radius lies right on top of the x-axis, so at this point, it's the closest I can get. The measured angle BAD is virtually 0. If you notice, the x value is 1 and the y value is 0, which makes perfect sense. In the ordered pair that we have identified in the coordinate plane, when the radius lies on the positive x-axis, this ordered pair has to be 1, 0. So this is our x value and this is our y value. Now in the context of our new definitions for our expanded values, or definitions of our sine and cosine and tangent trig functions, now we can apply our ideas this way. So the sine of a 0-degree angle would equal the y value, which is 0, divided by the radius, which had a length of 1, or it's still just 0. The cosine of a 0-degree angle is equal to the x value, which is 1, divided by the radius, which is always going to be 1. And then the tangent of a 0-degree angle is equal to the y value divided by the x value. So the y value is 0 divided by the x value, which is 1, which is 0. So these are the trig values for sine, cosine, and tangent. I'm only going to do this one time, but we're going to look at the cosecant of a 0-degree angle. Now the cosecant is the reciprocal of a sine. So if I reciprocate a sine, which means I'm going to have the radius length over the y value, which is 1 divided by 0. This is undefined, since we cannot divide by 0. Then we're going to do the secant, which is related to the reciprocal of the cosine, which says reciprocate 1 over 1. Well, that's an r over x. The length of the radius is 1. The x value is 1, so we still get 1 for the secant. Then if we do the cotangent of theta, it would equal the reciprocal of the tangent, which is x over y. So our x value is 1 and our y value is 0, which again gives us an undefined value. So when you do your trig functions, for these 6 trig functions, you're going to get values of 1 or -1, 0, and undefined. So there's our first quadrantal angle. We're going to try a couple more quadrantal angles, and now I'm going to rotate the angle from 0 degrees, and I'm going to approach 90 degrees. Now again, just make some observations about the length of the red line, which is your y values, and also the length of the blue line, which are your x values. As we approach 90 degrees, our y values, or our red line, approaches the length of the radius, and our blue line approaches 0. So it's just the opposite is happening. By the time we get to a 90-degree angle, we now can identify this ordered pair in our coordinate plane as 0, 1. X and Y ordered pair. Now if we have our X and Y ordered pairs, now we can find all of these trig functions over here based on our X, Y, and R. So the sine of a 90-degree angle is equal to the Y value, which is 1 over 1, 1. The cosine of a 90-degree angle is equal to 0 over 1, which is 0. And the tangent of a 90 is equal to the Y value over the X value, which is 1 over 0, which is undefined. So you can find the other trig functions here as well by doing the reciprocal, but I'm going to keep moving on with this idea. Now we're going to go to another quadrantal angle. Remember, quadrantal angle means we have to keep moving our terminal side until we hit one of the X or the Y axes. So as we move closer to 180, we can see that the Y values are decreasing and they're approaching 0. The X values, this is a little glitch that I have in this program. I'm having a hard time getting it, but as soon as we go to the second quadrant, our X values are to the left, which means they're going to be negative. So those are negative values. So they're approaching not a positive 1, but they're approaching a negative 1. And as you see this, as I get it right on 180 degrees, as close as I can, that's pretty close. Now the X value takes on the value of a negative 1, the Y value is 0, which makes perfect sense in the relationship where we rotate 180 degrees. Now our radius is lying directly on the x-axis. We are directly 1 unit to the left of the origin and 0 units up. So X, Y. And now we can find our 3 basic trig functions. The sine of a 180-degree angle is equal to the Y value, which is 1 over, the Y value, which is in this case 0, over the radius of 1, which is 0. The cosine of a 180-degree angle is equal to negative 1 over 1. The length of the radius is always positive, so negative 1, because it's a positive divided by negative. And the tangent of 180 is equal to the Y value, which is 0, over 1, negative 1, which is still 0. So those are the 3 basic trig functions of 180 degrees. We'll clear that off. We're going to do one more. I'm going to rotate this around to 270 degrees. As we approach 270, you can see that the red line approaches a negative 1, and the blue line is approaching 0. And it would be, as expected, this ordered pair should be defined as the ordered pair that is directly 1 unit below, but 0 units left and right. This is our X, this is our Y value, and the length of our radius is 1. So we take the sine of a 270-degree angle. It's equal to the Y value, which is a negative 1, over the length of the radius, which is 1, or negative 1. Take the cosine of a 270-degree angle. It's equal to the value of the X, which is 0, over the radius, which is 1, which is 0. And the tangent of 270 is equal to the Y value, which is a negative 1, divided by the X value, which is 0, or undefined. So we just went around this whole quadrantal, all 4 quadrants of our unit circle, and these are the values that we were getting. Just to show you, if you go completely around again, the red line approaches 0, the blue line approaches 1, and a 360-degree angle is exactly the same as a 0-degree angle. We've wrapped around the circle once. Now those are the basic trig ratios for our quadrantal angles. They will not change. It doesn't matter what size of circle that you have. Remember, on our unit circles, grab the right one here, it doesn't matter if we have our circle bigger or smaller. As we move these back and forth, we're not going to change one bit our trig ratios because they are similar triangles, similar circles, so therefore our ratios won't change. So we just as well work with the simplest circle possible, which is our unit circle, and they will always be in these values. So let's go back to our original page here. What I've put on here then are the basic trig values for our quadrantal angles. I try to describe how we got those and what these values are. I believe those are all correct, and you can use that as a reference if you want. So my goal in this slide is to present to you the quadrantal angles and allow you to calculate the basic trig ratios of those quadrantal angles.